Okay, this session is going to be around troubleshooting and try to give some techniques on steps to try to troubleshoot issues in the field. So first want to start out, those of you who have been to our trainings before have seen this diagram, but the traditional planter harness, here we have represented rows 1, 2, 3, etc. Each row has its own wire. So pin 1 on this 37-pin connector, pin 1 is row 1, pin 2 is row 2, 3, 4, 5, all the way up to, I believe, 32. And then you have a power and ground and potentially a second power and ground in this 37 pin. So each row has its own wire that communicates to a brain module of some sort. So this is the way Gen 1s and Gen 2s can communicate in this manner. Air Force communicates like this, row flow communicates. Your way pins can communicate on this structure. Also a smart connector, flow sense, auxiliary flow sense, row flow components, kind of your traditional planner setup. And this is the way it's been for decades. Then when Precision came with their SRM based system, it's a completely different path and structure for planter harnessing. So it's actually two wires, a CAN high and a CAN low, but we call that a CAN bus. And there's a terminator on both ends that tell the system that this is the beginning and this is the end of the CAN bus. And then all of the components on the whole planner are tied in and communicate just over those two CAN high and CAN low wires. So we've got the 2020 display here, all the components on row 1, 2, 3, 4, however many, speed tube, furrow force, you name it that you plug in, they all communicate on this single harness wire concept. So you can see all the systems here that plug and play into this CAN bus. V-Drive, Delta Force, speed tube, smart firmer, HDs, flow sense, MSET, multi-hybrid, furrow force, and Gen 2s and Gen 3s can communicate in this manner to these components. So you can see the common denominator here is Gen 2 can communicate both with CAN bus and with the traditional harnessing. Gen 1s are limited only to the traditional harnessing, and Gen 3s, the new Gen 3, can only communicate with the CAN bus. So it is not compatible with Air Force and row flow type of systems. So I just wanted to kind of explain the differences between the two as a precursor for our discussion here. Okay, so as far as technique goes, I'm going to try to simplify it a little bit this year over what we've done in some years in the past. So I've had a cheat sheet in the past, but the real name to the game when I approach a planner or a troubleshooting problem, the key is isolation, isolation, isolation. I cannot stress that enough, to try to isolate the problem. Did it follow the meter? Did it not follow the meter? Is there any pattern to it? Is it on the left wing, center, right wing? Anything you can do to isolate or start narrowing down the potential problems or cause of problems is really the name of the game. So the first question that you always need to ask yourself is, do you have power? So there's blinking lights on just about all of the Precision modules, V drives, SRMs, RUMs, The Air Force row flow has a blinking light on the base harness. There's blinking lights on just about anything. And if there's no light, that means you don't have power. So nothing's going to happen if you don't have power. So do you have power is number one. And this isolation piece, have you swapped it with another row? Now, some components are easier to swap than others, I understand. And it's pretty much Murphy's Law that as soon as you fill the 3-bushel hoppers with beans, you're going to have an issue. And so trying to swap a 3-bushel hopper with its neighboring row is rather difficult. So I get that. But usually swapping hoppers and meters is fairly easy. Swapping weigh pins takes a little bit more time. Obviously, swapping hydraulic cylinders on Delta Force is much more involved and messy. So some components are easier, but swapping seed tubes is another thing to try. Swapping the SRMs or row harnesses is another technique, and you can really narrow things down quite rapidly if you're able to do that. Number 3 for me is the diagnose screen green? What's not green on the diagnose screen? And is everything else working normally? Kind of a tag onto that is, did this happen while you were planting in the field? Were you going through a waterway or over a terrace or turning on the ends where you might be in a flex? The planter might be flexing is another clue. But what else is not working? Or what else is working? And what is green and what is not green on the diagnose screen can help narrow things down. Have you tried to reset modules? When you reset modules, it basically it kind of resets or restarts the system and asks for new communication between all the modules. So and a power cycle does as well. And sometimes just a simple power off the whole monitor, power it back on can clear up some connectivity or syncing issues, that type of thing. Even on the iPad as well, power cycling that can work occasionally. Here's just some people ask, what do the blinking lights mean? So 1 blink per second, a 1 hertz blink is good power, good communication. That's what we're always looking for. If there's any light, that means you have power. But then, a solid light means you're updating firmware, and erratic and the 5 blinks tell us different things. But that 1 blink per second is what we're looking for, and know that we have a healthy system then. As far as in order of importance and diagnose sequence, like we said earlier, power is absolutely number 1. Nothing's going to work if you don't have power. Next after power is daisy chain for your SRM systems, and I will explain that a little bit further here in a minute. But you have to have a healthy daisy chain, or wake-up wire, some people call it, before you can continue on to CAN communications. So CAN to me is the same as communicating. They both start with C, so CAN is communication between the modules on that CAN bus. So that's the order of sequence you need to troubleshoot in: power, then daisy chain, then CAN communication. Okay, here behind me is a 5-row planter setup for an SRM system, and I just want to explain the harnessing structure because it is a lot different than our traditional planter. Power comes in from a different point than than CAN communication does. So I think it's very helpful just kind of from a basic level to understand the path and the communication of a SRM harnessing infrastructure. So it might be a little bit hard to see in the video, but over here we have our power source. This would be coming, the harnessing coming from the tractor. And the big wire up here is power, and the little wire here is CAN or communication. And they are independent of each other. In years past, they used to be in the same cable, but they have now broke that out because the big, powerful or power wires were abusive to the small little CAN wires, and so they run those separately now, independent of each other, back to your PDM. So this is your power distribution module. There's one on every planner, regardless of size. And from this point, it separates out CAN, come out underneath, and power. Your 5 power banks are shown right here in this particular example. We're using 2 of the 5, and they are fuse protected. There's a master fuse, and then each 5 port has its own specific fuse. So we're going to follow the CAN path here, and these at each connection on my CAN, I have a orange zip tie to help me identify locations that I can move my CAN terminator to, which is at the end of our harness, back at these orange zip tie points along my planner to help with troubleshooting. So we've got an orange zip tie here and an extension that runs to row 1, and we have to communicate in sequence from the PDM first to row 1, in sequence to the end of the planner, which is row 5 in this case, and then the CAN terminator tells the system this is the end of the planner, no more rows. So our CAN runs through what we call a backbone. This is kind of the lifeblood harness of the system. In this case, row 1 and row 2 are connected to this backbone. And then we are simulating going around a full point here with an extension, and my orange zip ties at each extension location, connection location, onto the second backbone, which in this case happens to be a 3-row backbone to make up my 5-row planner, and then the CAN terminator at the end. So that's CAN, or communication, we said. Power are these wires that come off of the bank on the front. So power is fed into the middle of each backbone. And you just get the necessary length extension to make it from the PDM to the middle of that backbone where you have a power tie-in. So this is, if you have a power issue with no lights, maybe on a wing or something, it's going to be in this harness. If you have a CAN or communication issue, a daisy chain issue, it will be in the CAN path, which is this extension to the PDM or the backbone itself. So now I want to explain a little bit of the daisy chain. So we said power was number 1. You got to have power. Number 2 is daisy chain. So every time you power on the monitor or reset modules, the system goes through an identification process. So it asks for communication among all the modules that are plugged into the system. It asks for communication back to the 2020, and they have to identify themselves. So that process takes place in the daisy chain, or some people call it the wake-up wire. So here we have a harness that's stripped apart, and in this harness, it's either the yellow or the orange wire. It depends on what revision of harness you have. But in this harness, it's the orange wire is the wake-up wire. So the only purpose that daisy chain wire serves is for identifying the modules on the can when you reset modules or power up, you know, at the start of the day. When you're actually running in the field, the daisy chain wire doesn't communicate to anything. It's just there. So the daisy chain is also in sequence from one continuous sequence, and it stops at, well, first it goes to the PDM. There is an SRM up inside the PDM, and that identifies as the first SRM. And then it comes to row 1, and it sees the SRM there, and the serial number assigns to row 1, moves to row 2, sees the SRM, the V drive, and the serial numbers, and says, okay, that's the next one, so that's got to be row 2. We move to row 3. Same process. Sees the SRM serial number, the V drive serial number, and whatever else components are plugged in, identifies that as the next row in line, so that must be row 3, row 4, row 5, and so on. So if there's a break in the daisy chain, say here on row 3, if there's a break in the daisy chain, it can be broken on the orange wire coming into the SRM or the orange wire going out of the SRM to the next row. So if there's a daisy chain break, it can either be the row that's shown on the 2020 or one of the rows either two. It depends on where in the harness that wire is broken. So a daisy chain on the diagnose screen is shown by a blinking line. And on some of the newer software, it'll actually call out daisy chain break. But a blinking line anywhere on your diagnose screen is indicative of a daisy chain break. So we have to be able to accurately identify all the modules on the can and where they're located in sequence, and that's done via the daisy chain, before we can continue on and try to diagnose a CAN problem or a communication problem. So sometimes daisy chains are intermittent, meaning there's a line flashing on the screen and you reset modules and it goes away for a half hour or 5 minutes and then it comes back, and those can be kind of hard to find and diagnose because it's sometimes there, sometimes not. But if you have a break in the daisy chain, essentially what happens is all of the modules on past that daisy chain, the 2020 doesn't really, it might see them, it might see the serial numbers, but it really doesn't know where they're located at. And so you really can't operate in that manner if the 2020 doesn't know where everything's located on each row. So the daisy chain is very important as the modules identify themselves anytime we reset modules or power up at the beginning of the day. Okay, here we're showing, we got the Gen 2 diagnose screen pulled up on this 5-row planner setup, and I've sabotaged one of the row harnesses so that we show CAN errors. So right now it's not flashing, but a common cause or symptom of CAN errors is that I call them ghost issues, where it doesn't make any sense. The PDM will flash gray and then red and then back to green, or any of the rows can flash red or green or gray or yellow, and it's just kind of comes and goes at its own will, and that would be indicative of CAN errors. I'm going to try to see it if I can wiggle a wire here and make a CAN error show up for you. There, we're getting some some different flashes there. So, Clint, if you want to back up, here and show the whole board. So what I've actually done is over here on row 5, I sabotage a harness. The can air actually happens to be here on row 5. So I'm going to take my can terminator off from the end of the harness here, and I'm going to move it to one of these flex points. You know, another spot with these orange zip ties on. I'm going to plug my can terminator in there. So what I'm going to expect to see now is hopefully row 1 and 2 green, and if that happens, we know this extension is healthy also. Since we're terminating after the extension, rows 3, 4, and 5 are going to turn red, and that's expected because we're eliminating them out of the system. So we're going to reset modules here, and rows 3, 4, and 5 will turn red, and the PDM and 1 and 2 should turn green, because we know the problem's on row 5. Out in the field, you wouldn't know that. So here's an example of isolation with the can terminator. Now we know the problem's not on rows 1 or 2 because they're green, and it's got to be on rows 3, 4, or 5. So let me take this can terminator off and plug this back in. Put this down, put this back here. Put this back in. And just like that, we're getting can errors all across the system. And all we did is move the can terminator back to the end of row 5, and we happen to know that the issue is on row 5 in our little simulation here. So that is how you can use a can terminator to work your way backwards and identify which portion of the planter a can error is on. That terminator only works for can errors. It will not really help you identify daisy chain or power issues. I also want to show this plug here. This is a simple daisy chain bypass plug that we have available, and it can be used for diagnosing daisy chain breaks. If you suspect there's a daisy chain at a row, you can simply disconnect that plug from the backbone, insert this daisy chain, and reset modules. And so it's going to it just connects the circuit. It's going to bypass that row, and if the break's on that row, it's going to move all the rows back. And so the very last row is going to turn red because you bypassed that one row in the middle. And all the modules past that re-identified themselves. So using this plug will cause the last row to turn red, but it can be used to pinpoint that there is indeed a daisy chain break on a certain row if that blinking line disappears when using this plug. One other thing I want to bring to your attention is if you are installing RUMs or HDs, or I've got a SRM here in the field as a replacement, I want to point out these tabs on the back of these. Depending on what row unit you're installing on, you snip these tabs off they're kind of like an anti-rotation, so the thing won't rotate on you once you bolt it up. But if whatever tabs are clipped on the one you're taking off, clip the same tabs on here, because what can happen if you don't clip the tabs and you bolt that up to a planter frame, a road unit frame, you can put this module in an incredible amount of stress if you really crank on the bolt, because the tabs are holding it out and it flexes this tab, and you can cause these things to fail prematurely. So we've definitely seen that in a few cases where these tabs were not properly snipped, and just that simple step of snipping those tabs caused this module to flex when it was bolted on really tight. So be aware of that when you're switching these out in the field. One other little trick here, around touchscreens and calibrating touchscreens. So Gen 1s or Gen 2s, at any time, if you just hold your finger on the screen for like 8 or 10 seconds and don't let go, it puts it into a calibration mode, and then you touch the crosshairs and it says successful. So that's good for Gen 1s and Gen 2s. If where you're touching on the screen, you know, the little X isn't following your finger push, that would make you maybe want to do that. Another little trick is to use a business card and insert it between the screen and the green housing, and just run that around the perimeter a few times like that. I've definitely seen times where dust particles, you can't even see them, get wedged between the screen and the green housing, and just a simple business card can dislodge that dust, and then do a calibration after that, and that can save your screen. I don't think I've replaced any Gen 2 touchscreens. Definitely have replaced Gen 1s. Touchscreens, they seem to last about 7 or 8 years depending on use, but those are repairable to send in and get new touchscreens put into Gen 1s. I do about 2 or 3 a year, so be aware of that. One other point I want to make on a Gen 3, I don't have that here to show right in this video, but on a Gen 3, if you hold, on the map on a Gen 3, if you hold your finger on the, say you have the population map up on your Gen 3, if you hold your finger and long press on the population little box or downforce box or whatever you have map on the screen, long press for 8 seconds will automatically rebuild that map on the Gen 3. So just a little tip there on an easy way to rebuild maps from the Gen 3. So another thing that I do on my planner inspections, and you can certainly do at any time during the year yourself on any of the monitors, Gen 1, 2, or 3, I'm going to show you on a Gen 2 here, is your health check. So in the Gen 2, it's setup, systems, and then this health checks button. And so whatever health checks pertain to what you have installed will populate here. In my 5-row planner simulator, we have some V drives set up, so I'm going to actually run a health check. Don't have vacuum, so I'm going to run a no load voltage current and press continue. And then it's asking you to hold up these outside 2 switches. And so they are running. And apparently on row 4, we had a fail, and a live demo is always dangerous because you never know what's going to happen. And I was not expecting that. So at any rate, we have a failed V drive on row 4. So you can do that, any of those health checks at any time that you want during the growing season. If you suspect there's an issue with a certain system, you can run a health check and see what failed or what passed, etc. And in this case, row 4 failed, so we would need to identify what I would probably run it again and see what failed. If it failed a second time, then I would go back there and probably swap that meter or hopper with the row beside it and see if it follows the V drive. Would be the absolute first step I would take to, again, try to isolate the situation. So what happened there on row 4 was this, the SRM light was not blinking. And so that meant we didn't have any power. So all I did was unplug the plug and plug it back in. And I think the connection was just a little bit loose on that SRM. And so we plugged it back in, got the blinking light, reset modules, and now it's healthy and working again. So kind of fooled the instructor there for a second. One last thing I just want to show, just so you're aware, is a new tool that I have as a dealer, is called Mobile Max, but it's a 2-row planner in a box. So this is a case that I can bring out to the field with a Gen 3 and a known good system. I can take full control of any row on your planner. We can swap harnesses out, PDM, or not PDM, SRM, to try to isolate a known good system to what might be wrong on your planner. So excited about the troubleshooting capabilities that I have as a dealer to support you with this 2-row planner in a box. And then we'll also show this, this is the mobile test stand, liquid test stand. It's not so mobile. It is mobile, but not very easily mobile. It's very heavy. Liquid test stand. So if you have HDs or flow senses that you're questioning if they're operating correctly, just like we test meters in the winter, we can now test liquid to ensure full functionality before heading to the field. Prior to this test stand, this mobile liquid test stand, we would have to actually hook your planner up to a tractor, power it up, and then do the troubleshooting techniques on those HDs, whereas now we can do it in the shop on a workbench. So just wanted to make you guys aware of those things that I have access to now as a dealer.